Okay, so what is work? Work is a force exerted through a distance. Okay, so that's the definition of work. Okay, there must be some conditions met in order for work to be done. Okay, an object must move. Okay, and the force and the displacement must be in the same direction. So they can't be perpendicular to each other. They have to be in the same direction. Okay? Just kind of as an aside, if the work is parallel to the displacement but opposite direction, then the work is a negative number. Okay, so it's like friction would be opposite of where you're going. So friction is like negative work, and where you're going would be the positive work. Okay? All right, so how do we calculate this? Okay, so the symbol for work is a capital W. The unit for work is a joule, which is a capital J. Okay? And the formula, if you're doing the formula, there's two formulas. The general formula that it takes is work is equal to F times S, where F is force in newtons and S is displacement in meters. Okay? Now, if you're doing work at an angle or up an incline or something like that, then your work is equal to F times S multiplied by cosine theta. Okay, where theta is the angle of the incline taken with respect to the horizontal, not the vertical, the horizontal typically. Okay. Okay, so what are some examples of work versus non-work? Okay, so I have kind of 4 little examples of things that are happening. Okay, so let's say, here's my first example. A dog pushes a ball horizontally 5 meters. Okay, so you got a little dog. Okay, and he's pushing the ball on the floor with his nose. And he pushes it for 5 meters. Okay, so he's exerting a force in the same direction that the ball is going. Okay, is the ball moving? Yes, the ball is moving. Okay, and so if the ball is moving and it moves a certain distance and the force and the ball are moving in the same direction, or at least in the same plane, okay, then work is being done. Okay, so this is work. Okay, here's my second example. Your mom carries a pizza across the room. Okay, so mom is carrying a pizza, which means she's holding a pizza up. She's working against gravity. Which plane is gravity in, the X or the Y? The Y. And if she's moving across a room, she's probably moving horizontally. So which plane is that in? Your X. So the force is in the Y, the displacement is in the X. Are those in the same plane? No. So if your force and your displacement are not in the same plane, that is not work. So that's non-work. Okay, so here's a third example. A car's brakes are applied and it decelerates to stop. So the car is moving, you hit the brakes, and the car slows down until it stops. So you have a force being applied. So if your car is moving one direction and you apply the brakes, which direction is the force applied? The opposite direction, because brakes are like friction. So, but is the force in the same plane as the motion? Yes, if it's moving horizontally, yes, it's applied in the same plane. So that's okay. Now, it's moving horizontally, so the displacement that it covers over that time is in the x-plane as well. So if your displacement and your force are in the same plane but opposite directions, is that work? Yes, it's still work, but what kind of work would it be? Negative. So it is still work, but it's negative work. Okay, car brakes are just like friction. Friction is negative work. Okay? All right, and then I have a fourth one. I've kind of run out of room, so I'm going to put it over here. But here's my fourth one, okay? A tugboat pulls a boat that doesn't move. Okay, like maybe it's too heavy, maybe it's stuck in the mud, I don't know. But the tugboat is exerting a force, but the thing that it's pulling on doesn't move. So, is this work or not work?
It's not.
It's not work. So even though there's a force exerted, if there's no displacement, there is no work done. So that's non-work. All right, so here's a few examples. So Allison pulls a car at 12 meters against 50 newtons of friction at constant velocity, and we want to know how much work she does. Okay, so we know that we have 12 meters, right? This is your displacement. So that's your displacement. And you have 50 newtons of friction. But if you're moving at constant velocity, that's also equal but opposite to your effort force. So that's technically your force. And we're assuming she's moving horizontally, or at least your displacement and your force are in the same direction. So work equals force times displacement. You have F, you have S, you're looking for W. So you just plug it in. So 50 times 12. And these are in the correct units. Meters is the unit for displacement. Newtons is the unit for force. So my answer should be in joules if I'm using that. Okay? So when you plug that in, 50 times 12 in your calculator should be 600. And work is measured in joules, so it's a capital J. And that's it. Okay, so in this case, Allison lifts a 1.2 kilogram crate 1 meter. How much work did she do? Okay, so I have 1.2 kilograms, which is mass. That is not a force, that is a mass. And I have 1 meter, which is a displacement. So she's lifting it, right? Lifting it. So that means she's working against gravity. So I have to calculate Fg, okay? So Fg is going to be the force applied to lift the crate. So Fg is mg, and if she's lifting it, she's going opposite of gravity, so I'm not going to make gravity negative here, okay? So it's going to be 1.2 times gravity, but not negative, 9.81. Because you're going up, you want it to be positive, okay? Okay, so 1.2 times 9.81, and you get 11.772, so I'm just going to call that 11.8. And that's newtons. Work equals force times displacement. In this case, my force is my Fg because I'm working vertically. So that's 11.8, and that's in newtons. And my displacement is in meters. It's 1 meter. So that gives me 11.8 joules. Okay, third problem. A tugboat pulls, if I could spell, pulls a cargo ship with 1.8 times 10 to the 4th newtons for a distance of 2.5 kilometers at an angle of 22 degrees to the horizontal. And we want to know how much work is done. All right, so I have my displacement, my S, but it's in kilometers. I have my force, it's in newtons, so that works. I have my F, I have my S. Oh, and look, I've got an angle. So I've got an angle theta. Now, my displacement is not in the proper unit. It needs to be in meters. So how many meters are there in a kilometer? 1,000. So if I have 2.5 kilometers, how many meters is that?
1,200
Or 2,500 meters. Okay? I know. All right, so we're looking for work, and work is done at an angle. So work equals F times S, and since it's at an angle, we multiply it by cosine theta. So F is already in newtons, so we can leave that just like it is. 1.8 times 10 to the 4th. That's how many newtons. Your displacement, instead of 2.5 kilometers, it's 2,500 meters. And then we multiply that by cosine theta. Theta is 22 degrees. Okay, so we need to make sure our calculator is in degree mode. Okay, so the first thing we have to do is hit mode. Make sure your calculator is in degree mode. If it's in radians, it will not work. You have to put it in degrees. Okay? So then it's 1.8 second, comma, 4 times 2,500. You don't really have to put times. You can put times if you want to, but you just hit cosine, and then your theta is 22 degrees. It counts it as degrees as long as you have it in degree mode, and then enter. And that is a big number. Some people don't like to deal with big numbers and put them in scientific notation. Your calculator actually will do it for you. So if you hit the mode button, you can go to psi and make it blink black over psi, and then quit. And then if you want to see what you did all over again without actually typing it all over again, you hit second and then enter, and it will type it all over again for you without you having to type anything. And then hit enter again, and there's the number in proper scientific notation without you actually having to do anything. So then that's a little easier to read. That's just 4.17, and see the E7, that means times 10 to the 7th. So your answer is 4.17 times 10 to the 7th joules. Because it's work, it's in joules.